All right, so good afternoon to those who are here already. So, can you guys hear me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, that's good.
Yes, sir.
So, good afternoon to all of you. Wait lang natin yung iba. Anyway, very, very short meeting lang.
Yes, sir.
Okay, so let's wait one more minute. Baka may humabol pa. Okay, so there were two who have just joined. Okay, that's good. Oh, may umalis na isa. Kanina 14 na tayo tapos naging 13 na lang. Ayan. Oh, yun. 15. Alright, that's good. Oh, wow. Naging 16. Okay, so I guess nandito na lahat. Alright. So, let's start now our short discussion. Okay? So, Module 1 will talk about operational amplifiers. Okay, or in other words, we call this one op-amps. Is there someone here who has an idea what is an op-amp or where do we use such thing? Op-amps or operation amplifiers. Anyone? So it's like all of you are new to the word op-amps, or maybe you guys have already heard of it but doesn't really learn what is the meaning or what is op-amps for. Am I right? First time?
Yes,
Capacitor,
sir.
sir. It is used for capacitors and resistors, sir.
Used for capacitors and resistors. Para saan? Uh, yeah, it requires
Voltage,
for
voltage.
voltage. So what will happen to that voltage? Wala. So basically, from the word itself, okay, amplifier, so it amplifies the voltage or the current that will go inside of it. Okay. So the first thing that you need to know about op amps is it has a high gain. So when I say high gain, so it can transform a very low voltage into a high voltage. Okay. So yun na siguro yung pinaka generic or pinaka general definition ng op amps. Alright, so without a further delay, so we should talk about amplifier first before getting to the word op amps. Okay, so amplifier. So as you can see right here, we have a current or a voltage wherein once it passes through this device or an amplifier, it will, enlarge or it will make it larger. Right? So sometimes it's 10 times larger, it's 100 times larger, sometimes even 100,000 times larger, or even 1 million times larger. Okay, so that's how an amplifier works. So this kind of device is mostly used in speakers. Okay, so it converts that small voltage into a higher voltage to provide a higher decibels, okay, or sound. So going to the operational amplifier, it is being represented by this uh, nakahiga, okay, horizontal or basta nakahiga. Hindi ko lang paano explain. Nakahigang triangle. Okay, it's like this one. And then it has two inputs, and then we have here the voltage source positive and then voltage source negative, and then the output. Okay. So again, as I have said a while ago, op amps is a high gain. Okay. So when we say high gain, it converts this one into 100,000 times or 1 million times from the original source. Well, this is only applicable if we have an open loop circuit. But in reality, we don't use this one, okay, because this one is too high and it's uncontrollable. Okay, it's hard to maintain. So that is why we only have closed loop in real world. Okay, so itong output na to, to have a closed loop na tinatawag natin, so magkakaroon tayo ng feedback. This output will go to our input. So either of those two. So magkakaroon tayo ng discussion kung saan siya pupunta. So pwedeng negative, pwedeng sa positive. Okay? So operational amplifiers are linear devices that have all the properties required for nearly ideal DC operational amplification and are therefore used extensively in signal conditioning, filtering, or to perform mathematical operations such as adding, or that's the one that we are now calling summing amplifier, or subtract, or the differential amplifier, or even integration or differentiation. So take note, differentiation is different from subtract or differential. So that is why we've used subtract instead of differential. So baka malito kayo, differential tapos differentiation parang parehas lang. Okay, differentiate na lang yung 2 voltage. No, okay? So differential is different into differentiation. Okay? So ito yung magka-partner, integration saka differentiation at saka add saka subtraction. Okay? So basically this is what we use as a fundamentals analog device before until now actually. Okay? So kung may makita ka mga gadgets na ganun wherein it can do summation gamit ang mga buttons, so pwedeng yung buttons na yun is nagtatransmit ng voltage or current. And then, kung ilang beses mo siyang pindot, or pwede namang via, ano bang tawag dito? Via, ang tawag dito sa photoresistor, parang ganun. Pwedeng photo through or via photoresistor. Tama ba yun? Photoresistor, yung napipihit. Okay, so pwede mo kontrolin yung voltage na pumapasok. Hindi photoresistor is for light. Ano bang tawag doon? Yung meron 3 pin, tapos pwede mong kontrolin. Anyone? Nakalimutan yung pangalan. Para siyang radio.
Sir.
Ano yan?
Potentiometer.
Potentiometer. Photoresistor. Potentiometer yun. Okay, so pwedeng ganon. Okay, so kung meron ganon, so, and then, naglalabas or nag-display siya ng, let's say, addition, subtraction, integration, or differentiation. Ang fundamental sa ginamit doon is operational amplifier. Okay? Alright. So, the first thing that you need to know about operational amplifier is, basically, okay, lahat ng operational amplifiers are differential amplifiers. Okay, by default. Kasi kung papansinin nyo, it has 2 inputs. And then, ang mangyayari kasi niyan, kung bakit nasabing differential amplifier, lalo na kapag hindi pantay yung input natin sa positive at saka sa negative, ang ginagawa niyan is i-differentiate niya na kagad. Or, yun, magsusubtract na kagad. May own calculation or may formula kung paano natin makakompute yung voltage na lalabas dito. Okay? Pero, kung gusto natin ng isa lang, okay, we call that one non-inverting or the inverting op-amps. So for now, we'll discuss non-inverting op-amps. So when I say non-inverting, our voltage input, okay, our voltage input will go through positive pin. Okay, kaya nga tinawag na non-inverting eh. So take note, we have 2 pins. The one is negative and the other one is positive. So if it's non-inverting, your voltage input should go through positive. Okay? And then kagaya ng sabi ko kanina, open loop, masyadong mataas yun. Ito, meron siyang gain ng 100,000 or umabot pa ng 1 million. That is only applicable for open loop. Okay? So, hindi siya ganun ka-useful, lalo na sobrang taas na nun. Okay? So, that is why we have this closed loop wherein magkakaroon tayo ng feedback resistor para papasok ulit siya dito. So, parang may looping siya dyan para makontrol natin. Okay? Hindi siya ganun kataas. Yes, masasacrifice yung potential na mag-create siya ng mataas na voltage, pero controllable naman na siya. Okay? So, unlike before, nagre-range siya ng 100,000 to 1 million. Ngayon, pwedeng times 10 na lang. Like, your 1 volt will become 10 volts. Your 2 volts will become 20 volts. Like, napaka-ideal niya na kumbaga. So, yun yung pinaka-gusto nating ma-attain, which is a closed loop circuit, just like this one. Okay? So, we have here a feedback resistor and then input resistor. Okay? So, where am I now? So, in this configuration, the input voltage signal or the Vin is applied directly to the non-inverting, which is the positive pin. Okay? Input terminal, which means that the output gain of the amplifier becomes positive. So, take note, if it's non-inverting, so whatever is the sign, hindi naman sinabing porket non-inverting, lahat na ng output niya is positive. Okay? That's a no-no. Kung ano yung sign ng voltage input mo, yun din yung magiging sign ng output mo. So if I have a negative voltage input, then I will also have a negative voltage output. Pero mostly, of course, in reality, hindi naman negative yung ginagamit natin. Okay? So ginagamit natin is positive voltage. So this one is positive value only. Okay? So this one is in contrast to inverting amplifier, wherein, again, in real world, ang ginagamit natin is positive. So kapag ginamit natin yung positive sa inverting, ang result is negative. Pero dito, sa non-inverting, whatever is the sign of your voltage input, then it will stay as it is. Okay? So the result of this, that the output signal is in phase with the input signal. So kung positive, positive din siya. Okay, parehas sila ng phasing. Pero doesn't mean na equal sila ng phasing. Parehas sila ng phasing, pero hindi same yung output, okay, or yung value. So we have here the formula if ever we have this kind of circuit, okay. So kapag ganito yung circuit diagram, then we can simplify this one as having this formula. So V out is equal to 1 plus RF, feedback resistor, divided by the R1 or Rin, okay, times the V in. Okay? So, para ma-appreciate nyo itong formula na to kung bakit or paano ba siya gumagana, so we having an example. So, example of non-inverting amplifier. So, we have a given here. So, we have 9 kilo ohms for the feedback resistor and then 1 kilo ohms for the Rin. Okay? And then 1 volt for the voltage input. Okay? So, find V out. So, here's the solution using the formula that I showed to you a while ago, this one. So V out is equal to 1 plus RF divided by R1 times V in. So basically, lalagyan mo lang yung mga values. Ano ba yung RF, ano ba yung Rin, ano ba yung V in. Okay, so RF is 9K. And then divided by 1K, which is our Rin, times V in, which is 1. So if you're going to simplify this one, then 9K divided by 1K is 9. Okay. Simply cancel yung K. So 1 plus 9 is equal to 10. And then 10 times 1 is 10. So as you can see right here, from 1 volt, it became 10 volts. Okay? So, ganun na siya ka-effective as an amplifier. Okay? Or this one is non-inverting amplifier rather. Okay? Hindi lang, kasi maraming klase ng amplifier. So we have to be specific. This one is only applied to non-inverting amplifier. This kind of formula. Okay, so we have a different formula for inverting amplifier, differential amplifier, and then summing amplifier. Okay. So did you guys get it so far for the non-inverting amplifier?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
So kung sakaling nabibitin kayo dito, meron actually step-by-step derivation. Like for example, nandito yung voltage natin. Okay, saan na siya napunta? Okay, ano na yung voltage niya mula dito hanggang dito? Or dito hanggang dito, ano na yung current niya? Okay, so may derivation to dun sa pinagkuhanan ko. So, nilagay ko sa reference. Ibigay ko na lang sa inyo mamaya. Pero, hindi naman siya ganun ka-importante. Pero kung gusto nyo na malaman kung saan napunta yung voltage up to this point, up to that point, so meron doon, step by step. So, tignan nyo na lang sa reference ko mamaya. Ang ginawa ko kasi is nag-straight to the point na ako. So, kapag meron kayong ganitong circuit, actually, ganito naman lahat. Ganito naman mostly lahat ang circuit ng non-inverting amplifier. So, ito yung formula niya talaga. Okay? Para hindi na magulo o hindi na paligoy-ligoy pa. Right? So, the next thing that you need to do is verify whether this one is doable in LT Spice or no. So, yes, this is doable since nagawa ko naman na siya. So, gawa na lang ulit tayo ng bago. Saan na yung circuit natin? Okay. Palitan ko na lang to. Alright, so first we need an op-amp. Okay? So, para makakuha kayo ng op-amp, punta lang kayo dito sa mga components or click F2. Okay? So, magpapakita na itong mga components. So, dito, merong op-amps. So, double click nyo lang yan. And then, magpapakita lahat ng klase ng op-amps. So, napakarami niyan. Okay? Pero, hindi to kompleto. Okay? Meron at meron pa rin kulang dito sa library ng LT Spice. Okay? So, sa ngayon, ang gagamitin natin is itong Universal Op-Amp 2. Okay? So, this is just a generic op-amp. Meron pang mga ibang klase na mas maganda dito. Pero ito na lang muna since simple lang naman yung gagawin natin. Okay? So, click nyo lang yan and then click OK. Okay? And then, kung papansinin nyo, okay, sir, ba't parang may nadagdag? Itong positive side sa taas at saka negative side sa baba. So, don't worry, di-discuss ko kung para saan itong nasa taas at saka nasa baba mamaya. Okay? We call this one rail voltage. Okay? So, parang ito yung magiging peak-to-peak voltage natin mamaya. Pero mamaya pa rin. Papakita ko sa inyo kung ano yung magiging difference. Alright. So, the next thing that we'll be needing is two resistors, the R-in and then the RF. So, R, para lang sa shortcut ng R. So, para i-rotate, control R. Okay? Can you guys follow? Pwede nyo na rin gawin habang ginagawa kung gusto nyo gawin na rin yan. So, hindi na mahalaging arrangement. Ang mahalaga is alam mo na ito yung value nito is ganito and then value nito is ganyan. Okay, so, since example lang naman siya, hindi ko na siya in-arrange. So, ito yung RF natin. And then, ito naman yung R1. Okay, so, hindi ko muna papalit yung pangalan. Lagyan muna natin yung value. So, RF is 9K and then RIN is 1K. So, RF, 9K. So, right-click mo lang mismo yung resistor para magpakita to. Itong value ng resistance. And this one is 1K. Alright? So, connect muna natin. Ito yung feedback resistor natin. There you go. So, from here, pwede na natin palitan para hindi kayo masyado malito. Okay? So, right-click na lang din yung R1. From there, you can now change R1 to RF. The same with R2. So, this one is RE or R1. R1 ba? RE. Okay? And then, the next thing that you'll be needing is this one, the voltage input. So, from here, kukuha na tayo ng voltage source. So, click F2 again and then type voltage. So, pwede nyo namang hanapin isa-isa pero sa akin kasi tinatype ko na lang para mas mabilis. Okay, so voltage. And then, okay. Okay, so lalagay ko lang siya dito. So, check the polarity. So, positive to positive. Okay. And then, our V in is 1 volt. Okay. And then, dapat meron tayong ground, of course. Okay. So, ito, nakakonect din siya sa ground. Ayan. Okay. So, kung i-simulate nyo na to, wala kayong makuha ang result. Actually, magkakaroon kayo ng error. So, set muna natin. So, 50 milliseconds lang yung running time. Check natin kung walang error. Uy, walang error. Tama ba? Check natin yung result. 0.5 millivolts. Okay, so yun yung kulang. Okay, wala siyang error, pero kulang. Kasi dapat, kapag kinompute natin yung Vout, dapat ang makukuha natin is 10 volts, kagaya nito. Pero dito, ang nakukuha natin is 0.5 millivolts. So that is why, ito na yung magiging usage ng rail voltage natin, yung positive at saka negative side. So, ito yung mga sinauna, okay, kung bakit meron ganito. Ito yung mga sinaunang amplifier na meron pang rail voltage, yung positive at saka negative. So, magkahiwalay. Okay? So, ito, yung positive side, ito yung peak voltage ng positive mo. And then, yung negative is yun naman yung peak voltage ng negative mo. Okay? So, palakihan ko lang para mas makita nyo. So, from here, maglalagay tayo ngayon ng peak-to-peak voltage natin. So, yun yung magiging reference voltage kung ano yung magiging output natin. Okay, so voltage. So, check nyo ulit yung polarity. So, dapat nakatapat dito. Positive to positive. There you go. And then, dapat ito is nakakonect din sa ground. So, clinic ko lang yung G, tatapat ko siya sa negative, and then there you go. So, connected na siya sa ground. The same with the other side. So, voltage. So, dito, another trick. So, pwedeng hindi nyo na i-flip, pero pwede rin naman kung gusto nyo i-flip. Kapag flip nyo, tapos pinalitan yung value neto, by default, negative na siya kasi yun yung nakatapat pataas. Okay, or yun yung nakakonect rather dun sa voltage natin. Pero kapag nakaganito, okay, kailangan natin palitan yung sign. Okay? So, gamitin ko na lang para hindi ka malito. Nasa taas yung positive. Connect natin. So, ito, dapat, kunyari, gusto natin ng 15 peak na positive and then negative 15 na peak na negative. So, dito, right-click lang and then 15. Positive 15 volts na yan. And then dito naman, since yung polarity niya is positive to negative and then kailangan natin ng negative 15 volts, kailangan natin maglagay ng sign na negative. And then 50. Right? And then connected din dapat ito. Okay? So, ito, makikita nyo lang yung difference kapag AC mismo yung input natin. Pero since DC siya, so flat lang yan. Okay? So, run lang natin ulit para ma-refresh. So, check natin itong mga values. Tama kaya? Alright, so check natin. So, there you go. So, meron na tayong reading ng 9.999. So, para mas makuha nyo yung accurate na value net or result, click nyo lang mismo yung VN002 or kung ano man yung pangalan na nagpakita dyan. So, in my case, yan. So, 9.9999918. So, bakit ganon? Bakit hindi eksaktong 10? Kasi, again, in reality, yung wire natin, hindi porket wire siya, wala na siyang kinukuhang resistance. So, meron pa rin resistance yung mga wires. So, napakaganda ng simulator na LT Spice kasi medyo makatotohanan yung nakukuha nating mga values. Unlike, eto, sa computation natin, it's exactly 10 volts. Unlike in LT Spice, we've got 9.9999. Alright? Did you guys get it so far?
Yes, sir.
Yes, sir.
Alright. So again,
Yes, sir.
kagaya ng sabi ko kanina, ito yung magiging reference nyo dun sa magiging output nyo. So kung papansinin nyo, yung result na nakuha natin out of this voltage input and then yung mga value ng resistance natin is 10 rather. So what if ginawa kong 8 volts lang to, itong positive supply natin. So anong magiging result sa tingin nyo? What do you guys think? Ano magiging value ng Vout natin? Anyone wants to guess? 8. So coming from Mr. Delighted, actually you are correct. Kasi ngayon yung peak voltage na natin. So run ko lang ulit, and then there you go. So, 7.99. So, hindi siya eksaktong 8 again, pero at least sobrang dikit. 7.99. Okay? So, ito yung nagiging limiter natin. Okay, itong rail voltage natin. So, kung kailangan naman natin ng negative, so, pwede naman. Palitan mo lang to into negative. Okay? So, kung ano yung sign ng voltage input mo, magiging negative din yun. So, from 7.99, it will become negative 7. Hindi. 15 pa rin pala to. Gawin kong 8. 7.99. Oops. Negative 8. There you go. So, eto. So, we now have a negative 7.99. So, again, whatever is the sign of your voltage input, then that will be the dominant side. So, meron na tayong voltage input na negative 1. Okay, so magiging negative na rin yung result. If this one is positive, then this one will become positive also. Or the result will become positive. There you go. So, 7.99. Right, so nagets no so far kung paano gumagana yung non-inverting amplifier natin.
Yes, sir.
That's good. All right, so moving on. Okay, very good. So moving on, if we have non-inverting, we also have inverting amplifier. Okay? Or inverting op-amps. So, ito yung circuit natin. Okay, so mamaya explain ko kung anong nabago, ano yung parang pinagkaiba nila. So, in this inverting amplifier circuit, the differential amplifier is connected with feedback to produce a closed loop operation. So, same pa rin. Meron pa rin tayong closed loop operation. So, papansinin nyo, same lang actually. Itong reference voltage natin is nasa taas pa rin, which is connected to the negative. And then our Rin is still on the upper side. Okay? And then, so when dealing with operational amplifiers, there are two very important rules to remember about inverting amplifiers. Okay? So again, this is only applicable to inverting amplifiers and differential amplifier. So, yung iba, iba na yung rule nila. So, the first two rules, or yung pinaka-importanteng rules, is no current flows into the input terminal. Okay? So what are those terminals? So we have the V2 and then the V1. Walang dumadaloy na kuryente doon. So actually parang ako din kanina nagtataka ako kasi imposible naman. Okay? Kasi input yun eh. Tapos saan napupunta yung voltage natin? Papakita ko mamaya kung parang bigla na lang naglaho. Okay? Biglang nawala yung current natin mula sa point na to, mula papunta dito. Kahit dito rin, wala ring voltage dito or wala ring current dito. So, either of those two, so walang current. Pero, meron na tayong current mismo dito sa output. Pero wala sa input. Okay. So, di ko alam kung bakit gano'n. So, however, in real world, op-amp circuits, both of these rules are slightly broken. So, totoo to, pero meron pa rin konti since, yun nga, meron pa rin dumadaloy, pero sobrang liit or it's negligible na kumbaga. Pero meron pa rin, not actually zero, pero meron, pero sobrang liit nga lang. Okay? So this is because the junction of the input and feedback signal X is at the same potential as the passive input which is at 0 volts. Okay? Kung papansinin nyo, ito kasing ground natin is connected din dun sa voltage input natin. So that is why parang instead of going to have a clockwise flow of current, so yung iba napupunta dun sa reverse, okay, which is yung virtual earth natin. And then zero ground junction virtual earth. So because of this virtual earth node, the input resistance of the amplifier is equal to the value of the input resistor. So parang may effect siya kasi connected or iisa lang yung connection ng ground nila which is a virtual earth. So Rin and the closed loop gain of the inverting amplifier can be set by the ratio of the two external resistors, which is the Rin and then the RF. And then again, here's the formula for the inverting amplifier. So initially, what we're trying to get here is the gain or the voltage gain. And then this one can be derived by having this one V out divided by V in. And then from here, you can have another derivation which is now equal to negative RF divided by Rin. So again, ito, may derivation to, okay, dun sa reference sa pinagkuhanan ko. So pwede nyong tignan kung paano tayo nag-come up with this V out divided by V in and then negative RF divided by Rin. So since ang kinukuha lang naman natin sa inverting or sa amplifier, okay, is just the V out, so we can derive this one or we can simplify this one into this one. So V out is equal to negative RF divided by Rin times V in. Alright, so ito yung magiging formula mo kung ganito na ganito yung circuit ng inverting op-amps mo. Okay? So, ano na yung difference nila, sir, sa circuit? So, parehas lang actually. Nandito pa rin yung Rin natin. Nandito pa rin yung RF. And then, ang pinagbago lang is nandito na ngayon yung voltage input natin. Okay? So, connected na siya sa inverting pin. Kaya nga tinawag na inverting eh. So, kapag non-inverting, nakakonect yung voltage input natin sa positive. And if it's inverting, then nakakonect naman yung V in natin sa negative. And then, since wala nang connection to, so grounded na lang to, ang positive pin natin. And then, yun lang naman yung nabago. So, same pa rin naman. Okay, so let's have an example. So, we're going to use the same value. Oops. Mali to, mali. So, di ko napalitan. So, ang gagamitin nating circuit is this one. Okay, so grounded na dapat to, and then nandito na yung voltage input natin. So, ito is sa non-inverting. Okay, ito yung gagamitin nating circuit. So, anyway, so using this formula, V out is equal to negative RF divided by Rin times V in. Okay, we'll be having this result. So, RF is 9K again, and then Rin is 1K, and then V in is 1. So, whatever's the result, so 9K divided by 1K is 9 times 1. This is still 9, and then multiply by negative. So negative 9 volts. So from the word itself, inverting, the original 1 volt will become negative. So it is not in phase, but the opposite phase. So yung positive mo na sine wave, kapag sa output, negative yun. Yung negative mo na input sa inverting, positive yun. Okay, so kabaliktaran. So kung meron kang input na negative, you'll have a positive output. Okay? And then, yeah. So, ang papansinin nyo, another thing maybe na makikita nyo is dito, merong plus 1, pero dito wala. Okay? So, yung plus 1, applicable lang yun sa non-inverting. And then, itong walang plus 1, ang napalit naman is yung negative sign. Applicable yan sa inverting. Okay? Alright, so, 4 minutes na lang natitira, so I think hindi natin matatapos to kasi i-introduce ko pa yung mga laboratories nyo mamaya. So, puputulin ko na ngayon and then magkikreate na lang ulit ako ng bagong link and then join na lang ulit kayo doon para doon na natin itutuloy. Okay, para hindi maganda yung or hindi pangit yung pagkaputol ng meeting natin. Okay, so goodbye for now and then see you on part 2. Okay? So there were...
sir.
Goodbye. Yeah. Okay. Inverting amplifiers. Okay. So yeah. Natapos naman natin properly yung example. So the next thing that we'll be doing is by doing it on the Altis files itself. Okay? So again, mali ito. Ang dapat na gagamitin natin is itong circuit na to. So yung pinagkaiba lang is yung kanina, nandito yung voltage input natin sa non-inverting pins. Ngayon, yung input na natin is nasa nasa inverting pins na. Okay? And then, ito is grounded. Right? So, gawin natin. So, same pa rin yung RF sa RIN. Ang nabago lang is yung voltage input natin. Okay? So, voltage. And then this one now is grounded. The same with the positive voltage. Also grounded. So, wala pa rin tayong babaguhin dito sa rail voltage. Same pa rin sila. So, ito yung magiging limiter natin. Wherein the peak-to-peak voltage is positive 8 volts to negative 8 volts. Alright. So, same pa rin yung reference voltage natin. And then, reference voltage. Feedback resistance rather. And then, yung Rin natin. Okay? Same pa rin yung value, which is 1 k. And then for V1, 1 volt pa rin. So, in here, we expect to have, ano yung kanina? Iba naman na to. We expect to have negative 9 volts. Okay? So, check natin kung negative 9 volts ba yung magiging reading. Ay, dapat pala mas mataas sa 9 volts. So, any value, as long as it should be higher on the computed result of our voltage input. Okay? Bakit iba na? So, 12, 12. Which is positive. Sorry. Negative 12 pala dapat ko. Ayan, there you go. So, beware na lang dito sa mga signs ng voltage source na dapat ito is positive and then dapat is negative. Okay? So, positive, negative. So, there you go. So, meron tayong negative 8.99 or 9999. Okay? So, kagaya kanina, hindi naman eksaktong 10. Ang nakuha natin is 9.999. Alright. So, any question or clarification so far regarding with inverting and non-inverting amplifier? Hello? Alright. Okay, so wala kayong katanungan. Alright. Okay, so kung wala na, so let me introduce to you your laboratories. Okay. So, ang nakalagay dito, first activity. Okay, pero papalitan ko na lang yung pangalan. Pero ito kasi is composed of 3 laboratories already. Okay, so isi-send ko to, pero this one is composed of 3 laboratories already. Okay, so LT-SPICE activities, instruction using LT-SPICE emulator, show and find the V in and V out. So V out na lang tayo. So before na-require ko sila ng V in. Show and find the V out or design waveform of the schematic of the following. Okay, so kanina, ang ginamit lang natin is DC. Ngayon, gagamit na kayo ng AC. Okay, so last meeting, pinakita ko sa inyo kung paano nyo ma-set into AC voltage yung DC. So, ito yung indicator na sine wave na siya. Okay, or AC waves na siya. So dito, meron tayong inverting amplifier. And then it says reuse LP1001 model of op-amps. So paano ko malalaman na LP1001 siya? Ayan. So kanina yung ginamit ko is universal op-amp. Ngayon naman ang gagamitin nyo is LP1001. So you should find this model. LP1001. Okay? And then may step by step na kasing sinabi ko dito. Pero ano kaya? Kasi gusto ko sana, papagawan ko yun ng LP SPICE project and then kahit anong value na ng inverting amplifier para maiwasan yung kopyahan. Okay? Para own values mo na, kumbaga. Kasi na-notice ko last time na turo ako ng signals and sensors, like literally, 30 sila, 25 doon pare-parehas. Okay? So, sinasabi ko na sa inyo to agad-agad para hindi kayo magkopyahan. Okay? So, you should do it on your own. Okay? Kasi ultimo yung haba ng wire, parehas. Yung haba ng ganito ganyan, parehas sa parehas lahat. Hindi man lang nagkonti ng iba. Okay? So, nakakainis lang kasi yun nga, nagkopyahan sila. So, eto, hindi ko napapalitan. Naniniwala ako sa inyo na hindi kayo magkokopyahan. Okay? Though, yung yung sagot kasi ng iba. Sir, bakit naman iibahin namin yung sagot? Parehas naman yung tanong. Okay. So, hindi naman porket parehas, so dapat parehas sa kagaya nito, laboratory. So, pwedeng magkaiba kayo ng length ng wire. Pwedeng iba yung namings nyo ng resistors. So, mga ganun, mga simpleng bagay. Kasi yun, literally, parang parehas lahat eh. Okay. So, sana iwasan natin yung ganung bagay. Okay? So, right-click the V1. So, tinuro ko naman na kung paano iset yung mga voltages last meeting. So, kayo nang bahala. So, meron siyang amplitude ng 1, frequency of 30, and then in edit simulation command, go to transient, set the V3, and then stop time to 2, time to start saving data, 0, maximum time step is 0.01, and so on and so forth. Okay, so dapat ganito rin yung magiging parang settings mo. Okay, so trans 02001. Okay, para iisa lang yung magiging result or yung waves na makikita ko. So from there, dapat i-measure nyo na dito kapag nagawa nyo na to lahat, and then itong mga configuration. So i-measure nyo na rin dapat dito yung Vout. So yun lang yung pinakakailangan kong i-check. Okay? So screenshot neto at saka nung Vout. Okay, yung dalawang yon. So dapat parehas neto. Okay? So pwede nyo ibahin basta parehas yung wiring, parehas yung design. Ano naman design? Yung man tawag dito, schematic. Okay? So pwede nyo ibahin basta parehas. Ang gulo, pwedeng ibahin pero parehas. Ano yun? Anyway, basta hindi eksaktong ganito. So you can have your own design or schematic. So parang ganun. Okay? So if we have inverting, we also have non-inverting. Okay? Yung mga binigay kong example kanina, so those are with the use of DC. Ngayon naman, with the use of AC. So eto, AC to. Yun lang naman yung nagbago. And then the rest, medyo similar na. Okay? So ito yung magiging second laboratory nyo. So gagamitin nyo yung same configuration. It's just a different schematic. Kagaya ng pinakita ko kanina. Okay? So nasa na yung VIN natin? Saan na siya napunta? Alright? So LT1001 pa rin yung gagamitin nyo. Okay? Yan pa rin yung model ng op-amp na gagamitin nyo. And then the third one, in this schematic, you will be using LM741. Okay? So once na na-figure out nyo na kung paano maghanap ng mga model dun sa LT-Spice, merong mga model dun na wala. Okay? Kasi hindi pa naman lahat ng mga data sheets is na-import dun. Kagaya nito, LM741. Sobrang tagal na rin nito pero hindi ko alam kung bakit wala siya sa LT-Spice. Maybe hindi na na-update yung library ng creator. So LM741 is not in the list of components in LT-Spice. So as an additional knowledge, I would like you to search on the internet on how to add a new component. Okay? Specifically, an LM741 op-amp. So itong pag-add ng LM741, hindi talaga siya literally na masasave, pero pwede nyo i-save. Okay? Pero kung yun yung nahanap nyo, okay lang din naman. Pero kung yun yung hindi nahanap nyo, okay lang din naman. Ang importante, na-import nyo itong LM741. Kasi kapag nag-yung schematic kayo, hindi nyo pa rin siya mahahanap dun sa mga components. Kailangan nyo pa rin siyang import manually. Okay? So, hanapin nyo sa internet kung paano mag-import ng mga components sa LT-Spice. So, gagamitin nyo itong Spice Directive. Okay? Magda.include kayo dito and yung mga susunod pang mga steps. Okay? And then, gagamit kayo ng DC operating point. Okay? So, DC op yung gamitin nyo. So, skip nyo tong transient. Punta kagad kayo sa DC op. And then, kung ano man yung result na na-print out na ito, kapag clinic nyo yung run, yun yung kukunin nyo, yun yung screenshot na kukunin nyo. So, hindi siya sine wave, kundi mga numbers. So, pakita ko lang sa inyo saglit. So, sa simulation, edit simulation command. So, sa DC of point, so click nyo lang okay. Then, kapag niran nyo yan, ganito yung magpapakita. So, ito yung kailangan ko. So, i-screenshot nyo lang ito or snipping tool. And then, paste nyo lang doon. Then, ako na bahala. So, same lang din sa hinihingi ko sa number 1 and number 2. Dapat meron kayong ganitong schematic. Okay? So, ito na yung mga values na kakailangan niyo. So, for R1, 10K, 10K, and then R2 is 10K, 10K. So, sobrang dali na lang. Okay? And then, wala na kayong ilalagay dito sa 1 and 5. Dito sa B plus minus, yun na yung 15 volts, 15, 15. Positive 15 and then negative 15. Then V1, V2, I think may values naman na itong mga to. V1 to V2, yeah, same lang din, 15 volts, 15 volts, which is itong rail voltage natin. So, connected siya dito, connected siya dito. Okay, so for now, yun lang muna yung mga laboratories na papagawa ko. So, tatlo. Inverting, non-inverting, and then on how to import a certain component. Okay, so any questions so far?
Answer.
Answer.
You guys sure? Alright, so kung walang katanungan, then that's it. So hintayin nyo na lang itong mga uploaded files ko kasi ayusin ko pa to. May mga ayusin pa akong format dito. And same dito sa module, itong prinisan ko, may ayusin din ako dito. Itong picture mismo ng inverting amplifier. Alright, so yeah. See you next meeting kung sakaling i-announce ko na meet ulit tayo. So for sure, once nag-meet ulit tayo next meeting, meron ulit kayong bagong laboratory. So, dalian yung tapusin yung tatlo, di ba? Sobrang dali lang naman. Okay? Alright, so yeah, that's it. Kung wala na question or clarification, then you guys may now go.
Thank you, sir.
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 Thank you then. Okay. Okay, so good afternoon. Hello, can you guys hear me?
Good afternoon, sir.
All right, so that's good. Okay, so last meeting we have just finished up to this point, inverting amplifier. Okay, so are you guys ready now to have a discussion on the next topic that you go to do with your laboratory? Are you guys now ready? Or
Sir.
Yes, sir.
Yes, sir.
you guys have any concerns or question before we continue this discussion? All right, so I guess none. So the next one is differential amplifier. Okay. So in differential amplifier, so we also have tools, which is kind of the same with inverting amplifier. So no current flows in or out of the inputs. So what are those inputs? Right here at this point, V sub A and then V sub B. If you're going to measure this one on the LP spice, you will read nothing. Yes, in 0 volts. And then the second rule here is the op amp tries to keep the inputs the same voltage, which is, for example, your input here in V sub 2 is this voltage. It will try to equalize that one on our second input. Okay, so that is why V plus is equal to V minus. So whatever is also the input of your IR1, so you can see right here, this one is your IR1, is equal to your current on the IRF. Okay? The same with the IR2. Whatever is the current on this resistor will be your current also on the IRG. But then again, so if you're going to take a look on this one, we don't have any currents that flows in these two inputs, V sub E and then V sub B. So it's like a magic. So if you're going to take a look on this one is not connected on this V out anymore. Okay, so for some reason, the current is like jumping on our V sub out. Same with our V sub 1. So at this point, okay, of course, since we have a loop here, then that's obvious that this current will flow to our V sub out. And if you're going to take a look on this one, we have this node and then node here also. Those are the things that we call virtual ground. Okay, so that is why if we have a current here, it also passes on the other grounded area. Okay, so that is why we call that one a virtual ground. Okay, so this is a standard operational amplifier which has 2 points, inverting and then non-inverting. So we can also connect signals to both of these inputs at the same time, producing another common type of operational amplifier circuit called a differential amplifier. So last meeting, we have discussed one input only, which is an inverting or non-inverting. But once you have 2 inputs, like for example, this one, so input on the inverting and then another input on your non-inverting, this one now is called differential amplifier. Okay. Okay, so let's have an example of this differential amplifier. So we have this scenario when the resistors R1 is equal to R2, sorry, and then R3 is equal to R4. The diagram on the right for the differential amplifier can be simplified to the following expression. So if ever that this R1 is equal to this R2, and then R3 is equal to R4, then we could say that this one can be simplified using this formula, which is V out is equal to R3 divided by R1 times V2 minus V1. Okay, so it's very simple. If you have the same values for R1 and R2, same with R3 and R4. However, if you have different values, okay, like R1, this one. If we have R1, okay, which is not equal to your R2, and then R3, which is not also equal with your R4, you'll have to use this one, which is a more complicated formula. Okay. But for now, we will discuss the common or the same resistor. So we will go back on that one later. So let's have this example for differential amplifier wherein they have the same values of resistance. So we have here a given wherein R1 is equal to R2, wherein their values is 9K, and then R3 is equal to R4, wherein the values of those two resistors are 1K. And then for V1, it's 2 volts, and then for V2, it's 3 volts. So the question here is find V out. Okay, so just simply use this formula, okay, which is now this one, and then just simply substitute the corresponding values. So R3 is 1K, and then R1 is 9K. So 1K divided by 9K times. So your V2 here is 3 volts, and then your V1 here is 2 volts. Okay, so just simplify this one, and then you will get 9 volts. Okay. Oops. R3 is 1K divided by 9K. Is this correct? 1K divided by 1 over 9. 3 minus 2, 1. Looks like this one is wrong. Wait, let me correct this one. R3 divided by R1. R3 divided by R1. R3 is 9K. Sorry. So this one is 1K. And then this one is 9K. Okay. So it's the opposite. So our reference voltage is always higher than our series resistance in here, or our input resistance. So R3 and R4 is 9K, and then R1 and R2 is 1K. So that is why this one should be 9K divided by 1K. Okay. So sorry for that one. And then just simplify this one, and then you will get 9 volts. So did you guys get this one so far? So in differential amplifier, so we're actually getting their individual voltages. So for example, the voltage computed in your inverting amplifier, and then the voltage that is passing the non-inverting amplifier. So you can actually get their values one by one, like what we did in the non-inverting and then the inverting computation, and then just combine those two. Okay, but since we can use this simpler formula, then we will use this one instead. But you can also do the longer method, which is applying the non-inverting solo and then the inverting solo. Okay. So how do you do that? How do you do that one? So if you're going to solve for V1 and you're going to get the V out, so you have to ground this one first. Okay. So the same with the other one. So if you're going to get the voltage output of this V sub 2, you have to ground this V sub 1 also. Or just by simply making this voltage 1 equal to 0. Okay. But then again, since we can use this, simplified or more simpler formula, then that's the one that we're going to use. Right? So did you guys get this one or no? Hello? Can you guys hear me? Are you guys still there?
Yes, sir.
Yes, sir.
So how is it going for the differential amplifier? Can you guys follow or no?
We can follow, sir.
That's good. Okay. So I hope all of you can really follow. Well, if ever that you have a question or clarification, so feel free to ask me anything. Okay. So yeah, that's it for the differential amplifier, and then having same resistance value for R1 and R2, and then R3 and R4. Okay. So maybe the next thing that you want to do is verify this one in the LTSpice, whether this one is really correct or no. Okay, so let's do this one in LTSpice. So I'll just create a new schematic. So we're going to use op amp, universal op amp. Okay. And then we need 4 resistors. So this is for the reference voltage of the inverting, and then the reference voltage for the non-inverting. And then another input resistance for the R1 and R2. And then 2 voltages for the non-inverting and then the inverting inputs. And then another 2 voltage, okay, for the rail voltages, which is this one. Okay. Then all we need to do is connect them using wires. Okay, so this is our reference voltage. And then this is our R1. So I'll just arrange this one like that. Maybe you guys cannot see this one. I'll just put it here. There you go. And then you can just simply put here ground. And then for the second input, for the non-inverting, so we have here the reference voltage, which is also connected to ground. And then the another Rin, which is now connected to your inputs, or input number 2. Right, so another wire here and then another wire here. So our R3 and R4 is 9K, and then R1 and R2 is 1K. Okay. So this one is 1K, this one is also 1K, this one is 9K, and then this one is also 9K. And then I'll just change the variable names. R1, R2, R3, R4. We have the same R1, R2, R3, R4. R1, R2, R3, R4. Okay, that's good. And then we have here the rail voltages. So we have here the positive supply and then the negative supply. And then connect this one into ground also. And then this one is 2 volts, and then the other one is 3 volts. So V1 is 2 volts, and then the other one is 3 volts. Okay. What else? Right, so I guess we are already done. So that's it for the schematic. So let's now try to simulate. So just click run, and then we'll simulate this one in 50 milliseconds. Oh, I guess there is an error. Sorry. So I forgot to put the voltages for our rail voltage. So I'll just put here positive 20 volts and then negative 20 volts. And then what else? Oops. And then we forgot to put the ground in here. Okay. So I guess that's it. So there you go. So right now I've just measured the V out, okay, wherein our reading is 9 volts. I guess it's no, it's not really 9 volts, it's 8.999. So just like last time. It's not exactly 9 volts, but at least super close to 9 volts. Okay. Wherein our result in here is 9 volts. Okay. So as you can see, they are just the same. So you can actually test this one using an LT spice. All right. So that's it for the same values for R1 and R2. And then the next one is having a different values for your R1, R2, R3, and then R4. Okay. So if this is a scenario and we still have the same diagram, then we can apply or we can solve the V out by applying this formula. So it's quite longer since you have different values for your resistors. So again, how did we come up with this kind of formula? So we have these derivations on the link that is included on our module. Okay, if ever that you wanted to know how they come up with such a formula. Okay, so let's have an example for this one. So in here, I've just set a different random values. So we have here 90 for R1, 3K for R2, and then R3 is 1K, and then R4 is 4K. Okay. So same voltages input, which is 2 volts and then 3 volts, and then same question. So find V out. So all we need to do is get that formula and then replace their corresponding values. And then once you have, say, calculated the final result, then you will arrive at 1.68 volts. Okay. So let's see if we have the same values if we're going to do this one in LT Spice. So do not analyze this one for now. So just analyze this one once our discussion is done. So I'm just showing to you guys that this is an example in actual, and then this is how to do that one in LT Spice. So 9K for R1, and then R2 is 3K, and then R3 is 1K, R4 is 4K, and V1, V2, 2 volts, and then 3 volts, and then find V out. So let's see. So there you go. We have here 1.68. okay, which is super the same with our actual result in this example. Okay, so were you guys able to follow?
Yes, sir.
So just verify this one later, okay, once we're done with our discussion. So for now, just take a look on this one that this is the substitute values for the corresponding formulas. Okay, and then we arrive at the result of 1.68 volts. Right? And then we have another one which is summing amplifier. So if we have deduction, okay, we also have summing or summation. Okay. So in summation, our inputs are in inverting amplifier, which will make our result negative. Okay. But the one that we're trying to make work in here is the voltages that is being input to our inverting input. So V1, V2, and then V3 should add up and then should arrive with a single output. So the summing amplifier is another type of operational amplifier circuit configuration that is used to combine the voltages present on two or more inputs into a single output voltage, as what its name trying to imply, summing the voltages and then uh, making it into a single output. So if we add more inputs resistors to the input, each equal in value to the original input resistor, which is the Rin, we end up with another operational amplifier circuit, which is called the summing amplifier, okay, or the summing inverter, or this a voltage adder. So it has a lot of names, but the most common name of this one is summing amplifier, okay, which is also shown on the right side. Okay, so this one is very simple. So if ever that you're going to remove V2 and V3, this one is already an inverting amplifier. But since we have additional two inputs, okay, which also has additional two resistor inputs, this one now is making the or composing the summing amplifier. Okay, and then your non-inverting input is grounded. Okay, so for you to appreciate this one, so let's have an example. So we have these derivations. If you want to get the single currents on each of those nodes, so for example, this one or this path, so you can get this one by getting the V1 divided by Rin, or R1 rather. Or if you want to get the I2, so V2 divided by R2, or if you want to get the I3, which is V3 divided by R3. Or if you want to get the total current, which is the IF now, right here, so you can just simply add all of those currents. Okay? So again, just going back to the inverting equation, so in solving the V out for inverting equation, so you have to get the negative sign, okay, or basically just invert or negate the sign of your inputs. So if you have positive, then that one will become a negative. If you have negative, then that one will become positive. So in here, since we have positive inputs, then all you have to do is negate the entire formula. So negative RF divided by R in times V in. Okay. Well, this one is if you only have a single input. But if you have three inputs, then you have to use this one now. Okay. Which is basically came from the inverting equation, which is negative V out is equal to RF divided by R in times V1. So this is for the first line, this one. And then the second one is RF divided by R in plus, times V2. And then the last one is RF divided by R in times V3. So as you can see, we have patterns which can be simplified into, like this. Okay. So you can bring out the V1 and then have RF divided by R1 plus V2 divided by, times RF divided by R2, and so on and so forth. And then by simplifying this one further, you can actually arrive into a simpler formula, which we have in here right now. So RF times V1 divided by R1 plus V2 divided by R2 plus V3 divided by R3. Okay, and then it says here, etc. if ever that you have 3 or more inputs. Okay, so in summing amplifier, so you can have 2 inputs or 3 inputs or 4 inputs or more than. Okay, if there is only 1 input, then that is not summing amplifier anymore. That one is just an inverting amplifier. Okay, so were you guys able to follow on how we've come up with this formula? The last one, this one. Yes, sir, coming from Mr. Domain. Okay, how about the others? So you can use your mic. So don't be shy to speak. Okay? You guys have beautiful voices. So you have to maximize your resources para hindi mas nakakapagod, di ba? Mas nakakapagod mag-type. Anyway, so if you guys do not have a question anymore, then let's now proceed to the example. Okay, so we have here scaling summing amplifier. So find V out. Okay, so the given is already in here. So we have the R1, which is 1K, and then the R2 is 2K, and then the reference voltage is 10K, and then 2 millivolts for the first input, and then 5 millivolts for the second input. Okay, so in here, all we need to do is get this one, and then put it here. And since, as you can see, we don't have voltage 3 and then R3, then we'll just have to put 2 voltages and then 2 resistors also. So from negative V out, it will become negative. So we want to transfer that negative into the right side. So what is the value of RF? So it's 10K times your V1 is 2 millivolts divided by 1K. And then for the second one is 5 millivolts divided by 2K. So if you're going to solve this one, you will arrive at the result of negative 45 millivolts. So as you can see, you have positive inputs and then it's just simply inverted. Okay, or it was just simply negated. Okay, so from positive, it became negative. So let's see if we have the same results in using LT Spice. So what are the things that we have to change? So we can just remove this one. And this one is grounded. Yeah, grounded. And then another voltage for another input. And then another resistor for another resistor inputs. And then this one is also connected to ground. Oops. F9. There you go. So V1 is 2 millivolts and then V2 is 5 millivolts. So 2 millivolts and then 5 millivolts. Right? And then 1K, 2K, 10K. 1K, 2K, 10K. 1K, 2K, 10K. Right? And then I will not make changes on our rail voltages. So again, take note, these rail voltages are just our limitation when it comes to measuring this V out. So our maximum positive voltage is 20 volts, and then our maximum negative voltage is negative 20. Right? So let's see if we can have the same results. So there you go. So as you can see, we have negative 45, which is, or actually negative 44.99, which is super close with our result in here. Okay. Gets or no?
Gets or gets.
Yes. Okay. That's plus or okay. So it seems that most of you get it perfectly. Anyway, so this is the second type of summing amplifier wherein Rin is equal in values. So meaning your Rin or your R1, R2, and R3 are the same, or they have the same values. Okay. So if ever that is the case, then we can just simply use this formula. So this one is much more simpler when it comes to having a same values of Rin. So negative V out is equal to Rf divided by Rin times V1 plus V2 plus V3. Okay. And then of course you want to transfer this negative on the right side. So again, your positive inputs will become negative input, or vice versa. Your negative inputs will become positive output. Okay, so let's have this example. So we have here a given wherein Rin is 20K. So all of them are 20K. And then your RF is 20K also. And then V1, V2, V3 is 2 volts, 3 volts, and then 5 volts. So here the question here is find V out. So here's the solution. So again, where this one came from? From our simplified formula of summing amplifier. Okay, so just copy that one and then paste it here. And then just replace their corresponding variables into their corresponding values. So RF is 20K, and then Rin is 20K, and then V1 is 2 volts, and then V2 is 3 volts, and then V3 is 5 volts. So if you're going to simplify this one, so you can start here or start here, so anywhere. So I want to start here. So 2 plus 3 plus 5 is 10. And then if you're going to simplify this one, so 20K divided by 20K is 1. So 10 times 1 is positive 10. And then just simply negate that 1. So that is why we now have negative 10 volts. Did you guys get it? Okay, yes, sir. Coming from Mr. Martinez. Yes, sir. Coming from Mr. Zenizal. How about the others? Did you guys get it or no? Am I too fast?
Ito lang, sir.
No, sir, no.
Sakto lang.
Sakto lang, sir.
Okay, that's good then. Okay, so that's it for your additional laboratories. Okay, so again, so here are the links where I've got those topics. And then here's your additional laboratory. Okay, so this one is laboratory 4, 5, 6, and 7. So 4 and 5 is differential amplifier. And then 6 and 7 is for summing amplifier. Okay. So I will leave the analysis part into you guys. I have already shown to you on how to, come up with such, call this one, circuit diagram. Okay, so in here, we've just, copy this one into the same but just a different values. So the same with number 5. And then for number 6, so before we only have 2 inputs, but in here we now have 3 inputs. Okay, and then just follow the basic configurations that I put in here, and then make sure that you have done it properly without missing any step, so that you can arrive with the same correct answer as I have on my notes that I have saved. Okay, so 4 and 5 is differential amplifier, and then 6 and 7 is summing amplifier. So 6 and 7. So yeah, basically this one is the scaling summing amplifier wherein we have different values, and then summing amplifier Rin is equal, wherein our resistor inputs are equal. And then for number 4, this one is having the same values for some resistors like what we have discussed, which is R1 is equal to R2, and then R3 is equal to R4. And then for number 5, this one is having different values on all of the resistors. Okay, so the same instruction as before. So you're going to take a screenshot of your schematic and then the screenshot of your graph of the voltage output. So all of them have the same question. So screenshot of your schematic and then screenshot of your V out result. So Sir Duman. So Duman has a question. Sir, anong app gagamitin? Universal. So the one that you're going to use is, I think, I have indicated it in here. Wala nga. Alright. So
Meron
the
sir doon sa may kwan.
that you're going to use for number 4 and number 5 is universal op-amp. Okay. So there you go. I have just included that use universal op-amp. Okay. So same with number 6 and number 7. Right? So yeah, that's it for your 4th, 5th, 6th, and 7th laboratories. So any question or concern so far?
Sir, ako po.
Mhm.
Yung sa LM741 po sa past activity nga eh.
Mhm.
Pag iraran mo po siya ang sabi port pin mismatch. Mas mataas daw po yung instance nung sa may positive kesa dun sa ano.
So have you checked the polarities? So in here, I actually have an input for my rail voltage, which is positive going to negative, but I've changed the polarity or the sign rather of my voltage, which is negative. So you can actually put here just 20, but you have to make this into like this, wherein they are just the same. So this one now is negative 20 volts. So check this one. So most of us having troubles are on our real voltages. Okay,
Ay, sir.
check this one. Okay, and what else? I guess that's the only part that you're going to have an error. And then the rest, if ever that you miss putting any values, I guess you will not get any error. Okay. So any other concern or question? When did I? Oh yeah. So the deadline of your lab 1, 2, and 3 will be on this coming Thursday, right? So to those who haven't finished lab 1, 2, and 3 yet, so make sure to finish them before the deadline. Okay. And then what else? I guess that's it. So we will just discuss the following topics next meeting. And then of course, we're going to have new laboratories again. Okay. So yeah, you have a lot of laboratories, but they are just super easy and super simple. Okay. They are just super similar with the one that we have discussed on our module. All right, so yeah, that's it. So if you guys do not have a question anymore, so you guys may now go. And then thank you for attending on our Zoom meeting. I really appreciate it.
Bye, sir.
Thank you, sir.
Sir,
Bye.
thank you.
Thank you.
Thank you, sir. Bye.
Goodbye.
Thank you, sir.
Thank you too. Alright. Okay, so yun na nag-work mic ni Mr. Sarmiento. Bili ka na ng bagong mic.